All right, welcome back. So this time we're going to go through questions 121 through 140 of the AWS Machine Learning Associate Exam. Some questions and answers. Before we get started, hit the like button, subscribe, and share with anyone you know taking this exam. 121. An engineer is building a text classification model. The training dataset has 100,000 documents with very long text, on average 5,000 words. Training is taking too long. What can reduce training over time while maintaining quality? Truncate the documents to 512 tokens, use distributed training, reduce batch size, increase learning rate significantly. B, distributed training parallelizes computation across instances. It scales linearly with number of instances for large datasets. It handles long sequences without truncating data. It maintains model quality, so there's no data loss. And SageMaker supports distributed training natively. 4 instances means about 4 times faster training. Why the other answers are wrong. So truncating loses important information from long documents, reducing quality. Reducing batch size introduces or increases training time with more iterations. And a higher learning rate may prevent convergence, so it would reduce quality. 122. A company has an imbalanced data set for fraud detection, 99% legitimate, 1% fraud. After training, the model achieves 99% accuracy, but only catches 20% of fraud cases. What's the problem and solution? The model is working based on accuracy. The model is biased towards majority class. Use class weights. It needs more training data. The model is underfitting, increased complexity. B. So 99% accuracy is misleading with imbalanced data. A model predicting all transactions as legitimate achieves 99% accuracy. Only catching 20% fraud, which is B, low recall, is the real problem. Class imbalance causes bias towards majority class. The solutions would be class weights, oversampling minority, undersampling majority. Focus on recall for fraud detection, not accuracy. The class imbalance solution, the class weights, penalize the minority class errors more, SMOTE, generate synthetic fraud examples, and then have cost-sensitive learning. Why the other options are wrong? Working well. So 20% fraud detection is unacceptable. Accept those false positives. More data. This doesn't address the class imbalance. Underfitting. The model is actually biased. It's not too simple. 23. A pipeline needs to process data, train a model, evaluate it, and conditionally deploy only if its accuracy exceeds 90%. The entire workflow should be automated and version controlled. What AWS service is best? Step functions, SageMaker pipelines, Glue, or MWAA. SageMaker Pipelines is purpose-built for the machine learning workflow. There's native support for conditional steps, so you would deploy if the accuracy is greater than 90%. It integrates seamlessly with all SageMaker services. Version control is there for the entire pipeline. The model registry is integrated. ML Labs has the best practices built in, and there's automatic lineage tracking. You can see the pipeline steps. So why are the other actions wrong? Step functions is a general workflow. It requires more custom integration for this. Glue workflows are for ETL, not end-to-end machine learning. And NWAA works, but has a higher operational overhead. $124. A company is training a deep learning model on images. The model overfits on training data despite 50,000 training images. Which regularization technique will help? Choose 2. Increase the learning rate, add dropout layers, data augmentation, increase number of epochs, remove batch normalization. B and C. That's dropout and data augmentation. So why dropout? Dropout randomly drops neurons during training. It prevents co-adaptation of neurons. It acts as an ensemble of multiple networks. There's standard regularization for deep learning, and you can typically use the dropout rate of 0.2 to 0.5. Why is data augmentation correct? It creates variations of existing images. It increases the effective data set size. It prevents memorization of specific images. And there's common augmentations like rotate, flip, crop, brightness adjustment. And it's particularly effective for image overfitting. So why are the other options incorrect? The increased learning rate can cause instability and doesn't reduce overfitting. More ECOPs Epochs can worsen overfitting, and removing the batch norm actually helps with overfitting, but that's not quite the answer. 125. Which of the following visualization types can be used to spot outliers? Select three: box plot, scatter plot, heat map, bar chart, histogram, line chart. So, box plot, scatter plot, histogram. So, a box plot is specifically designed for outlier detection. It shows quartiles, median, and outliers explicitly. The whiskers extend to 1.5 IQR. Points beyond this are outliers. The visual representation of statistical distribution is there, and it's the best tool for identifying extreme values. Scatterplot shows individual data points in 2D space. Outliers are visible as points far from the main cluster. It's useful for multivariate outlier detection, can identify relationship anomalies. A histogram shows the frequency distribution. Outliers appear as isolated bars far from the main distribution. It identifies unusual values in univariate data, and it's easy to spot extreme values. Why are the other options incorrect? So a heat map is better for patterns and correlations, not outliers. A bar chart is good for categorical comparisons, and a line chart is good for trends over time. 126. A data science team at an email service provider has determined that the long-term cost of making or marking a bona fide email as spam is much greater than the cost of marking a spam email as bona fide. To address this, the team worked on a classification model to predict if an email is spam and boiled it down to two model variants. Model A, 95% accuracy with 40 false negatives and 100 false positives. Model B, 95% accuracy with 100 false negatives and 40 false positives. Which of the two models is more cost effective for the company? None of the model A or B are cost effective, or model B, or model A, or both models are equally cost effective. The correct answer is B. So model A, the cost of false negatives, so marking real email as spam, cost is greater than the cost of false positives, so spam in the inbox. So model A has 40 false negatives and 100 false positives. Model B has 100 false negatives and 40 false positives. Model A has fewer false negatives, 40 versus 100. And since a false negative is more costly, minimizing false negatives is the priority. Model A has 60 fewer costly false negatives. So the false negatives, that means a bona fide spam, right? It's a high cost. You might lose email, you might have lower customer satisfaction, more customer frustration. A false positive, that means spam going to the inbox. That's a lower cost because it's a minor annoyance. So model A minimizes the high cost error. Why are the other options incorrect? C. So model B has more false negatives, which are the costly errors. And then the other answers, model A is clearly better due to fewer false negatives. So this is cost sensitivity. All right. 127. A company is using SageMaker to train a computer vision model. The training data consists of images stored in S3 in various formats, JPEG, PNG. The engineer wants to optimize data loading to reduce training time. Which approach will provide the fastest data loading? File mode, pipe mode, convert all to record IO and use pipe mode, use fast file with S3. C. Record IO is optimized binary format for sequential reading. Pipe mode streams data without downloading the entire dataset first. This is a combination that provides the fastest data loading for images. So record IO packs multiple images into efficient chunks. It reduces IO overhead significantly, and it's a standard practice for large image datasets in SageMaker. What are the benefits? There's no wait time for dataset download. There's lower EBS storage requirements. It optimizes sequential access, and there's faster training start time. File mode. Why are the other answers incorrect? File mode must download the entire dataset first. Pipe mode with raw images is not as efficient as raw record IO. And fast file is not a standard SageMaker mode. Question 128. An ML model is deployed on a SageMaker endpoint. The company wants to gradually increase traffic to a new model version while monitoring its performance before fully switching over. What strategy should be used? Blue-green with immediate, canary using production variants, rolling deployment, recreate deployment. B, canary deployment gradually increases traffic to a new version. This uses production variants to split traffic. So 5% new, 95% old, and gradually does it. Monitor the new version performance with small traffic percentage and gradually increase if the metrics looks good from 5 to 10 to 25 to 50 to 100. And there's easy rollback if issues are detected. This minimizes risk to production. So the canary process, you can see there, start at 5%, monitor the metrics, increase if stable, and continue increasing until 100%. Why the other options are incorrect. Blue-green, immediate, there's no gradual increase, it's all or nothing. Rolling, this is for updates across instances, not traffic splitting. Recreate, this has downtime involved, so there's no gradual transition. Okay, 129. A data scientist has a data set with 50 features. Many features are highly correlated with each other. The data scientist wants to reduce dimensionality while retaining most information, the most important information. Which technique is most appropriate? PCA, random feature, random features with low variance, use all features with L1 regularization. Answer is PCA. This is designed for correlated features. It creates uncorrelated principal components, retains maximum variance in fewer dimensions, removes redundancy from correlated features, can reduce 50 features to 10 to 15 while keeping 95% variance, and is mathematically optimal for dimensionality reduction. So PCA handles multicollinearity, reduces overfitting, faster training, and preserves most information. Why the other options are wrong. So random may remove important features, so there's no optimization. It's random. Low variance doesn't address the correlation. And L1 regularization, this is a feature selection, but doesn't combine correlated features. 130. A machine learning model has high accuracy on the training data, but low accuracy on the test data. Which of the following changes would you recommend to address this issue? Select 3. Use more features, add regularization, remove regularization, add more training data, use less training data, use fewer features in the model. So B, D, and F. The problem is overfitting. So you need to add regularization, add more training data, and have fewer features. All right, so that overfitting, high training accuracy, low test accuracy. So with regularization, L1 and L2 regularization penalizes complex models. This prevents overfitting by constraining weights. It improves generalization to test data, and it's a standard solution for overfitting. More training data means there's more diverse examples to prevent memorization, and this reduces variance. It helps the model learn generalizable patterns, and it is a classic overfitting solution. Fewer features reduces the model complexity, eliminates irrelevant or noisy features. There's less opportunity to overfit, and there's simpler models. Simpler models generalize better. So why the other options are wrong. So more features increases complexity, which worsens overfitting. Removing regularization worsens overfitting, and less training data worsens that overfitting. It doesn't solve the problem. Question 131. An e-learning platform wants to generate audio versions of its course materials in multiple languages. The platform stores text-based course content in S3 and wants to automate the process of translating the text, generating audio files, and storing the audio back in S3 for easiest access. Which combination of AWS services will best achieve this? Translate to Poly and with a Lambda back to S3, Poly to LX to DynamoDB, Lambda to transcribe to SageMaker, comprehend to Poly to glue. Yeah, and it's A. Yeah, because translate will translate the text into multiple languages. So 75 plus. I think it's 80 plus by now. Poly will convert the translated text into natural sounding speech. And then the Lambda can orchestrate a workflow and store the audio files back to S3. So this can be a complete automated workflow. All the services integrate, and this is a cost-effective serverless architecture. So what this would do is read the text from S3, translate to the target languages, convert the speech, store the audio files in S3, and then repeat for each language. Why are the other options wrong? So using Poly to translate is not correct. Poly is a text to speech. Transcribe is speech to text, not text to speech. And comprehend is for analysis, not translation. Okay. 132, SageMaker automatic hyperparameter tuning. For SageMaker automatic hyperparameter tuning, what are the two required components? Choose two: the training algorithm, the performance metric, a fixed set of hyperparameters, the exact number of training jobs. So the training algorithm and the performance metric. So the training algorithm specifies which algorithm or custom script to train. It can be built in SageMaker algorithm or custom algorithm. It defines the model architecture. SageMaker applies hyperparameter combinations to this algorithm. The performance metric is an objective metric to optimize during tuning. SageMaker maximizes or minimizes this metric. So examples would be accuracy, AUC, F1 score, RMSE, or loss. And this must be defined to evaluate the hyperparameter combinations. You can see some Python code on the right-hand side showing the hyperparameter. So why are the other options wrong? Fixed values contradicts the tuning purpose. This needs ranges, not fixed values. And then the exact number, this specifies the maximum jobs, not the exact number. All right, next question, 133. After training a SageMaker XGBoost based model over a huge training data set, the data science team observed that it has low accuracy on the training data as well as low accuracy on the test data. Which of the following techniques would you recommend to help resolve this problem? Remove regularization, use less features, use more features, add regularization, use less training data, use more training data. So A and C, so this is underfit. So you need to remove regularization and use more features. So underfitting means there's low training accuracy and low test accuracy. So the model is just too simple. And the model cannot capture the underlying patterns. This means high bias, low variance. So to remove regularization, why would you do this? The current regularization may be too strong. It could be constraining the model too much. Removing this allows for the model to fit training data better. And this would increase the model's capacity. Using more features, why is this correct? More features provide more information. This helps the model capture complex patterns. It increases the model's expressiveness. It addresses insufficient model capacity. So what does this do for the solutions? You remove or reduce the regularization, you add more features, you increase the complexity, you train longer, and use a more powerful algorithm. Why are the other options incorrect? So fewer features makes underfitting worse. Adding regularizations would worsen the underfitting. Less data does not help this underfitting. More data doesn't address the model being too simple. 134. A research group at a university is leveraging census data to ascertain healthcare and social program requirements by province and city. Each respondent has provided answers to around 300 questions on the census form. Which combination of algorithms would you use to develop the necessary insights? Select two. Latent Dirichlet allocation, factorization machines, random cut forest, principal component analysis. So PCA. Oh, wait. Oh, I forgot k-means. Sorry about that. So PCA and k-means. So what's the analysis? There's 300 questions. There's 300 features. So high dimensionality. You need to segment the populations into groups. And the goal is to identify healthcare and social program needs by region. So why is PCA correct? This reduces the 300 dimensions to a manageable number, think 20 to 50. It retains the most important information, so a 95% variance. It removes redundancy and correlation. It addresses the curse of dimensionality and prepares the data for clustering. So K-means is correct because it groups the respondents with similar needs. It identifies distinct population segments. There's unsupervised learning, so there's no labels needed. It scales to large data sets, and it has interpretable results for policymakers. So two-step approach would be PCA reduces those features, 300 to 30 principal components. And K-means would cluster respondents into segments with 5 to 10 groups. Why are the other answers wrong? So LDA, this is for topic modeling in text, not census data. Factorization is for recommendation systems, not segmentation. And random cut is for anomaly detection, not clustering. 135. A company wants to ensure that its ML model complies with responsible AI principles. The company is particularly concerned about detecting and mitigating bias and model predictions across different demographic groups. Which AWS service should the company use? SageMaker Debugger, SageMaker Clarify, SageMaker Model Monitor, or CloudTrail? Clarify is purpose-built for bias detection and fairness. It detects bias in both training data for pre-training and predictions for post-training. It measures bias across demographic groups, meaning age, gender, race, etc. It provides fairness metrics and mitigation recommendations. It supports responsible AI governance. It generates bias reports for compliance. So it has these capabilities: pre-training and post-training bias metrics and detection, feature importance analysis, model explainability, and disparate impact analysis. Why are the other options incorrect? So debugger is for training issues, gradients or overfitting more, not bias detection. Model monitor is for detecting data model drift, not bias analysis. And CloudTrail is for API audit logging, not machine learning bias detection. 136. The marketing analytics team at a financial services company is working on creating a customer loyalty program targeted at specific groups of customers. Which data analysis techniques should be used for this goal? Clustering, multivariate visualizations, dimensionality reduction, bivariate visualizations. A, clustering. So clustering groups customers with similar characteristics. This is an unsupervised learning, so there's no predefined categories needed. You can identify distinct customer segments naturally. Each cluster represents a customer persona. This enables targeted loyalty program design. So clustering is for customer segmentation. You can group customers by behavior, demographics, spending. And within the cluster, you'll find high similarity. Between the clusters, you'll find high dissimilarity. So an example would be high value, growth potential, at risk, budget conscious. Common clustering algorithms include K-means. This is fast, works well for customer data. Hierarchical shows cluster relationships. And DB-scan finds clusters of arbitrary shape. Why are the other options wrong? So the visualizations are for data exploration, not creating segments. And dimensionality reduction reduces the features, but doesn't cluster. 137. A SageMaker notebook instance needs to be shared among multiple data scientists. The company wants to ensure that each data scientist's work is isolated and that they cannot access each other's files. What's the best solution? Create a separate notebook instance for each scientist, create separate user profiles in a SageMaker Studio domain, use IAM policies to restrict file access on a shared notebook instance, create separate directories on the same notebook instance. B, so SageMaker Studio user profiles provide complete isolation. Each user has separate storage and execution environment. A shared domain allows collaboration on projects and code. There's built-in access control and security, and you can share notebooks via Git while keeping data separate. It's cost-effective and manageable. So user profile has the following benefits: an isolated home directory, separate IAM execution roles, individual compute resources, shared domain resources. Why are the other options wrong? So separate notebooks works, but has a higher cost and management overhead. IAM is complex to manage and there's a risk of misconfiguration. Separate directories has no real isolation, so this is a security risk. 138. Only 3 of the built-in SageMaker algorithms support incremental training. What are those algorithms? Image classification, semantic segmentation, linear learner, XGBoost, object detection. A, B, and E. So image classification, semantic segmentation, object detection. So why are these incorrect? Image classification supports incremental training on new image classes. It can update existing models with new data. You can use pre-trained weights as a starting point, and this is faster than training from scratch. Semantic segmentation supports incremental training for new segmentation classes. You can add new object categories to existing models, and it preserves learned features from previous training. Object detection supports incremental training for new object classes. It can extend models to detect additional objects, and it's efficient for evolving detection requirements. Incremental training benefits include faster training, so 20 to 80% time reduction, lower computational costs, preserves previous learning, and adds new capabilities without starting over. Why are the other options incorrect? So linear learner does not support incremental training, and neither does XGBoost. 139. A neural network is being built for multi-class classification problem to classify images into 5 categories. What would be the best choice for activation function in the output layer? ReLU, Sigmoid, Softmax, TON. Softmax. So Softmax is designed for multi-class classification. It converts raw scores to probability distribution. So the output sums to 1.0 across all classes, and each class gets a probability between 0 and 1. This works with categorical cross-entropy loss. So the standard for multi-class classification would be 5 categories. So you can see the softmax output example with the predicted class highlighted. Why are the other options wrong? So ReLU is for hidden layers, not output layer classification. Sigmoid is for binary classification or multi-label, not multi-class. And TON is for hidden layers, which is outputs between -1 and 1. Question 140. A customer loyalty program uses a multi-class classification model to categorize customers into platinum, gold, or silver tiers. The confusion matrix shows platinum has TP 30, gold 60, silver 80. For each tier, there's various false negative values. What is the overall recall for this multi-class classification model? So, what's the formula for this? I think it's, oh, wait, I don't remember. It's total positives. Okay, so platinum tier, oh, wow. 30, so it's the total. Wait, 70, let's see this. 30, 70, 60, 40, 80, 20. Positives, false negatives, false negatives. So 70 plus 40, that's 111, that's 130. Platinum, gold, silver tiers. So 70 by 40, 40 by 20. How is this showing this? 30, 70, 20. But this is not. Oh, TP, TP, TP. And then the okay, and the false negatives are there. Okay, that makes a lot more sense. All right, man, I did not read that clearly. So it's a 30 to 70. Okay, 60 to 40, 80 to 20. That makes a lot more sense. Okay, so you're seeing the total positives to the total positives by false plus false negatives, right? So in that situation, all right, so 30 dividing 100, so it'd be about 0.3. So it'd be 60 out of 100, about 0.6. And then 80 out of 100 would be about 0.8. All right, and so you have to multiply these together, I believe. Yeah, so that's 0.8. And so you'd add all of these together, divided by 3, because there's 3 of them. Okay, so 0.6, that'd be 0.9. 0.8, that'd be about 1. 1.7 divided by 3 would be about just under 0.6, right? So it should be 0.57. There you go. Okay. So you see that. So incorrect. So if you know the calculation method, then you'll understand how that gets resolved. Oh, my goodness. Okay. That is all for this one. So we are going to stop here. Come back when we will go towards the next batch, 141 to 160. So thank you for joining. Before you go, hit the like button, subscribe, and share with anyone you know taking the AWS machine learning exam. Thank you. Have a good day.